shape. So let's start with it was, but let's start with, that's still a kite. Usually in algebra, the opposite b plus or minus square root of b squared minus 4ac over 2a. That's a shortcut formula for something that takes a lot longer to do.
What did you just say?
Okay? Quadratic formula.
Say it again.
Opposite b plus or minus square root of b squared minus 4ac over 2a. Okay? But that formula is a shortcut for completing the square, which takes about twice as long to do algebraically. Okay? So all your formulas that you come across in math, science, whatever content area are shortcuts. Okay? What kind of stinks, though, is that if we don't realize that they're shortcuts, we might be going through a problem that takes us, 10, 15 minutes to do. And you're like, this stinks. This is taking a long time. But without the shortcut formulas that you're using, that problem might actually take 40 minutes. Does that make sense? Okay? We worked on a problem today in trig, and I was just trying to prove a point to him. It probably took us 15, 20 minutes to do. Okay? But inside that we used like 6 different formulas. If we didn't have those formulas, that 20-minute problem would have maybe taken an hour. Okay? Now we were talking through it, so maybe 20 minutes we should have been without talking. Maybe it would have taken like 8. Okay? So then without talking and without formulas, maybe it takes a half hour. But even though it takes 8 minutes, that's a short time compared to the half hour that it would have been without the formula, right? So that's why I always show formulas, because I want you to have an appreciation that even though it might take a long time to get the answer, it's still a shortcut. Okay, it's our best shortcut. So this is a rhombus. In order to determine the area of a rhombus, we need to know some facts about it. And this is where Chapter 6 comes into play. And we have to be able to retain some of those properties from Chapter 6, which is hard. Okay? But what do you know about the diagonals of a rhombus? They bisect each other, and they're perpendicular. Okay? There's one other thing that they do. That's what's perpendicular. Okay, so you're saying that angle, that angle, that angle, that angle, that's 360? Okay, that's true. But I'm talking about these. These are the 360. But what do you know about that one compared to that one? Same. What about that one compared to that one? Same. So the diagonals bisect each other. So that and that are congruent. That and that are congruent. They're perpendicular. And they bisect opposite angles. So those angles congruent. Those angles are congruent. Okay, and these two are congruent. And like these 4 are congruent as well, right? And then the top 4 and the bottom 2 and the bottom 2 is a group of 4 congruent as well. So those are all true facts. But once we have all those true facts, and the reason I want to talk about those facts is because it creates some of our triangle congruency postulates. And it says that this triangle here is going to be congruent to all of them. Okay? So if I can figure out that triangle's area based off of some information about the rhombus, we should be able to come up with the area of a rhombus. Okay? So, if I know, so obviously the area formula for a triangle, let's look at that purple triangle. It would be area is 1/2 BH, right? Does that make sense to everybody? That'd be the area of that triangle. Now we need to know what B and H are. Okay? So the 8.53 number is not either of those, right? So B and H are going to be that distance and that distance, correct?
Yeah.
And it doesn't matter which one's B, it doesn't matter which one's H, but those are the things that we're going to be looking at. Okay? Now, we want to find the area of that triangle in respect to the objects of the kite, of the rhombus. Okay? We'll do a kite here in a little bit, and it's a very similar approach. But I want to write the formula for the area of a rhombus, obviously in regards to the information that I'm going to be given about a rhombus. And then usually the information that I'm able to obtain about a rhombus is its diagonals. Okay? So they're going to tell me something about this rhombus using that diagonal. So let's call that D1. Okay? Now, let's say that this distance here, you guys can't see that. This distance here is H for my triangle, correct? Okay? How does that H for the triangle, how could I write that in comparison to the diagonal of the rhombus? It's 1/2 D1. So H for my triangle is 1/2 D1. Okay? The next thing we will know for a rhombus is that thing right there. What do you think we're going to call that? That red one. D2. Okay? So that red one is D2. What do you think this is going to be called? That's B for my triangle, right? But what is B in regards to the diagonal number 2? 1/2 D2. Okay? So right now, finding the area of this purple triangle, I know that the B, the base of that triangle, is actually 1/2 of diagonal 2 for the rhombus, right? I know the height of the triangle is actually 1/2 the length of the diagonal 1 for the rhombus. So let me put, there we go, 1/2 D1. Okay? So, so that would be this. You're right, but let's go a little bit further here. If I were to multiply this out, what's 1/2 times 1/2 times 1/2?
0.2125.
Okay, so what's that as a fraction?
I don't know.
How do you know it's 0.125, but you don't know it's 1/8? 1 times 1 times 1 is 1, right?
Yeah.
2 times 2 times 2 is 8. So you get 1/8.
Wow,
Okay? You were right, but... So now how'd you do? Did you take 1/2 divided by 2, and you took 2.25 and divide that by 2? Is that how you got that? Okay. So then, I took that times that, I got 1/8. Now I got D1 and D2, right? So what that 1/8 D1 D2 is the area of that purple triangle, provided that I know what the diagonals of our rhombus are. Does that make sense? So if somebody says you got a rhombus that has a diagonal of 10 and a diagonal of 8. Multiply those together, give me 80, right? Take 1/8 of that, which give me 10. The area of that triangle would be 10. Does that make sense? Okay. Now, I'm not really interested overall in finding the area of that triangle. I want to find the area of the kite, the rhombus. Keep saying kite. I want to find the area of the rhombus. How many of those triangles are there in that rhombus? 4. And we said earlier